In this workshop, we will try to raise awareness to the audience of who we are and what we do. We will be introducing the research computing resources, support, and the training courses available from SharkNet, the province, and across the country. You see three logos here: Western, SharkNet, and the Digital Research Alliance of Canada. SharkNet is a Western-led high-performance computing consortium including 19 universities and colleges in Ontario, providing advanced research computing resources and support to researchers from Western and elsewhere in Canada. Digital Research Alliance of Canada is a confederation of advanced research computing consortia across Canada. Western and many other institutions across the country are its members. First, here's a summary of what everyone from Western has access to. For personal computers, lab computers, classroom teaching, you would go to appropriate group for your department and the faculty. There are IT groups on campus for such support. Science and the technology services for the Faculty of Science, the Social Science Computing Support Group, and the Engineering IT Group, and etc. The WTS has a list of IT support partners across the campus. For Advanced Research Computing, or HPC, research data management, mostly for librarians and people in humanities studies, you should come to SharkNet. Along with our counterparts across the country, we have much larger resources and provide the support and the training to enable and expedite your research. Here's the outline of the topics we're going to cover. First, we will talk about the supercomputing, what it is, where it is, and what it can help you with your research. Then, we will talk about briefly how to request more resources when your needs exceed the default. We will then discuss what everyone doing computational research should know about. And lastly, we will introduce the training courses we're running throughout the year. This diagram gives you a conceptual view of what constitutes the computational resources for advanced research computing and data management nowadays. Include three major components: supercomputer or clusters, cloud, and storage. Across the country, from coast to coast, supercomputers, clouds, and storage are provided by the regional partners of the Digital Research Alliance of Canada. SharkNet, under the umbrella of Compute Ontario, is a regional partner of the Alliance. With a single sign-on account, free of charge, one can access all of the supercomputers, clouds, and the storage services across the nation. Here's a quick view of what the Digital Alliance currently has. Across the country, we have currently 5 new systems: FIR, NOWL, NIBI, Trillion, and ORCAL across the country, and each one of them has over 100,000 CPU cores and several hundred GPUs, and tons of storage. And for those of you who have been using the Compute Canada, or now Digital Research Alliance of Canada systems across the country, these systems are being decommissioned. And here's a list of dates of closure. Cedar, Graham have already been closed. Niagara will be closed by September the 30th. And the Beluga is already closed, but people have access to the login node only. Why using national resources? If you do not have many cores or much memory, if you do not have the GPUs of the type you needed, or you need a huge amount of disk space, for example, hundreds of terabytes or even petabytes, or you need to run a large scale of simulations that need hundreds of cores, or you need a large amount of simulations concurrently instead of one after another, or you need to run web services, need to run SQL databases, or you need to run a program on a cloud, or you need any resources for doing your compute and the storage tasks at no cost. And here is a brief description of the procedure that you can get account if you don't already have one. First, learn and access if you need a lot of compute and the storage resources for your research. Discuss this with your peers, with your supervisor. And also, you can go to the Alliance website and find more details of what resources are available. Second, once you decided you do need an account and to access the resources available across the country, and to talk to your supervisor, get his or her CCDB role ID in the form of ABC 123 and the 2 followed by 2 digits. If your supervisor does not have an account yet, convince him or her to sign up for an account, and then you can proceed to step 3 to apply for an account. So go to the website above, sign up for an account, choose the appropriate role that fits you, whether you're a grad student or postdoc, a principal investigator, or external researcher. In that case, you will need a sponsor, a supervisor. And once you submit your application, then you can start exploring the resources. Normally, the application will take up to 48 hours to get a response, to get approved. Here's a summary of 3 tiers of access that one can get with account. Everyone has access to certain amount by default. For example, one can have access to unlimited number of CPU cores and the GPU cores, but very low priority. Therefore, you will expect to wait some time. I'll come to the point of why you have to wait. Simply just because you do not run your programs or called jobs interactively. We'll come to that just in a few moments. And second, you have access to the following storage spaces. First, 50 gigabytes of a home, 1 terabyte of a storage space, project space, which is also a workspace, and up to 20 terabytes of a scratch space, which is temporary, and then 10 terabytes of a nearline, which is archive, tape-based. And your group can also have access to cloud, up to 80 virtual CPU, up to 25 persistent cloud instances if you're running, for example, running websites and databases. And you can have access to up to 10 terabytes of space for volume and snapshots. And you can have access to these resources without asking a question. And the second, occasionally, one may ask a moderate amount of an increase from the default by email to the support. For example, you may ask for increase in the priority temporarily to your compute or GPU jobs. And you can ask for an increase for up to 20 terabytes of a project space across the country. Remember, across the country, there are 5 main sites, 5 clusters, and in total, you can have up to 40 terabytes of storage. And you can ask for increase nearline up to 100 terabytes. And for cloud, you can ask for moderate increases as well. And this request, you can request at any time by sending email to support@tech.alliance.ca. Now, if your group needs exceed these 2 tiers, then you need to consider tier 3, the resource allocation competition. With resource allocation competition, you can access at the least over 200 CPU core years and 25 RGUs, which is a reference measure for GPUs, throughout a year. You can ask more than 40 terabytes and more than 100 terabytes of storage for project and nearline spaces. And you can ask for more resources on cloud. And this, for this tier of access, you need to submit an annual application. This happens once a year, okay, in the late fall. There isn't a single entry point or hub from where the one goes to a specific site. You would have to memorize the list of sites for clusters and the cloud services across the country. There are 5 sites for supercomputers: FIR, NIBI, Trillium, Horcal, and Narval. And for cloud services, Arbutus, FIR, so Cedar, that should be replaced by FIR, and NIBI, and Beluga. Accessing the cluster services is through text terminal. Use the command SSH and the name of the cluster. This is a text-based. But we'll come to another way of accessing the clusters just in a few minutes. And the access the clouds is through a web browser. Now, how to access a cluster. Take a NIBI, for example, operated by SharkNet. You can go to the website ondemand.sharknet.ca in your browser, and then, you will be prompted for login. After you log in with your username and password and multi-factor authentication, you will see this interface. On the top, there are 3 options: a file, compute node, and the logging node. Under logging node, if you click NIBI shell access, it will give you a text terminal, and then you landed on the logging node. This is a text terminal. And by the way, all the clusters are running Linux operating systems, which requires you to be familiar with the Linux operating system and be able to move around and use a text terminal. And beside the logging node, there's a compute node. And under compute node, there are a few options, and you can ask for a desktop if you're more comfortable with a graphical interface. Click a desktop, and there's a request form, and you will pick your account. The reason for that is for research groups, normally you will have one or multiple groups. In my case, I have a couple of groups, and in your case, in particular, if you have a resource allocation competition or RAC account, and you will have a higher priority through that group account. So use that as you need. And then you specify the runtime. I think here you can ask for up to 8 hours for interactive use. And the amount of memory, to specify 8 gig by default. You can increase or you can decrease, and you can specify the number of cores, CPU cores. And for those of you, if you want a GPU acceleration, check this. Otherwise, you don't check. So I check that. And forget about the email option here, because and then you click launch. You click launch, and then you will see your request being put in the queue. This is because your request goes to the compute node, and the compute nodes are shared among users. You therefore you have to wait, because the compute nodes is not shared and not over committed. So therefore, you might have to wait. And in this case, looks like it's going to wait for a while. Let's come back to here later. Oh, here we go. It's ready, and I click launch desktop, and boom, and I have a Linux desktop. And the access to this desktop is quite intuitive. And under applications, then you have different options, the internet browser, and then under system tools, you have an option to open a text terminal. The text terminal, you will see you have access to your home directory, which has up to 50 gigabytes of storage. Okay, back to Open Demand here. And the third option here on the top menu, drop-down menu, is the file access. You click the home directory, and it will take you to the listing of files and directories in your home. And from there, you can upload and download the files by dragging and drop files from your local computer. So this web access, Open Demand, gives you a very convenient way of accessing a remote cluster. And you don't need anything else, any other software in order to access a remote cluster. All you need is a browser. We recommend use Chrome, and there are some issues with Firefox, and there might be some issues with copy and paste, but Chrome is known to work. Okay, back to our presentation. Here is the workflow. You start with your browser, and your browser has the access to the file, the file manager or file explorer. Then you can access your files. And also, you can request for a desktop or a terminal, and that gives you the concept of a workflow. Now, remember, the logging shell text terminal takes you to the logging nodes, while a desktop will put you on the compute node. So this will wait. Requesting a desktop will wait, maybe as you've seen, a couple of seconds, and while request for accessing a shell can take you immediately to the logging node. And here, these pictures show the workflow of running a job or jobs. As I mentioned just earlier on clusters, so you do not run your programs, called jobs, interactively. Instead, for each application or each program, you need to prepare a subscription script, which is a shell script. In this shell script, you will put these lines at the top, and the first section is the section for the scheduler commands and options. We're using a Slurm scheduler, And these are the commands. First, we specify the number of tasks, and this is equivalent to the number of parallel processes. In this case, I'm asking for 64 tasks or 64 processes. And the CPUs per task, I set to 1. This means I will assign the 1 core to per process. I'm not running any threads inside the process. Otherwise, I will specify, let's say, 2, 4, or 8 per process if I'm running multi-threaded code within process. And the next line, I specify the memory, the amount of memory per process. And the default could be a 4 gig. You can specify less, but it will be charged for the minimum for accounting purpose. By charging, I mean the charge for the usage to keep track of your usage and therefore adjust your group priority. It doesn't mean financially charge. Then you specify the runtime. This is important. You need always to specify the runtime. This is 30 minutes. And the accounting group I want to use, and I want to use my default account. For those of you who have resource allocation computation or RAC account, you should always use that in order to get the higher priority. So next section is the user section, and these two commands are completely per user. They have nothing to do with the scheduler, and you specify your particular command or the input, so the programs to run. In this case, this is an example of running a Julia code. Now, once you have this job submission script, in this case, I call it a run Julia Pi, and then you can submit your program using this command. You submit, and after you submit, using this script, you check your job status. It will show your job ID, and the status is in the PD, which means pending, or R, which means running. And that's a typical workflow. Next, accessing a cloud. A couple of notes. The Alliance provides a cloud as an infrastructure as a service. So not necessarily seen as a turnkey solution as one might have seen. So users are responsible for running a VM and tasks inside the VMs themselves. And typical uses of a cloud at the Alliance, web services, databases, compute-intensive applications as well, but at a small scale. Before you proceed, visit the Alliance Wiki page on cloud. So you go to Alliance Wiki page, docs.alliancecan.ca, and look for cloud. And you need to have a project to start with. Only the PI can create a cloud project per cloud. How to create a cloud project? You need to go to an online form, and this you can find the link of this form on the cloud on the wiki page on cloud. Okay, fill out this form. The PI will go ahead and fill out this form, and your request will be approved without a question within 24 hours. And once you have a cloud project, and then you can go to the cloud interface. Go pick one. Well, this project is per cloud. So for example, if you want to use a NIBI, you need to go to a NIBI and a request. The PI needs to open a project, and then once the project is created and approved, and they go to the NIBI, any group members can go to NIBI and log in. And once you log in, you will see this dashboard. And this is the place where you can manage your VMs. As I mentioned, your group is fully responsible for creating the VMs to choose what images you want to use, what operating systems you want to use, what versions. And all the images are Linux flavors. There's no Windows image. Okay, so all VMs are running Linux. And your group is fully responsible for managing your VMs and updating your operating systems and installation of software needed. Okay. Now, transferring files. As just mentioned, that you can upload and download the files through the open-on-demand web interface. But when you have a large amount of data to transfer, large amount of files to transfer, you better consider the use of a Globus. Globus is a web-based data transfer service. This is a global service, is not particular to Digital Research Alliance of Canada. With the Globus, you can copy data between your computer and another computer in the world, somewhere else, say down the States, at the University of Texas, and one of the labs that you want to transfer data in between. Provided that that remote machine can be accessed through the internet. In order to use the Globus, one needs to install the Globus, connect the personnel on your local computer. That's all you need, and it's very easy to use. Just go to the Computer Canada's wiki page and look for Globus, and from there you will get information on how to proceed. Where to get help online, and these are the two places you want to go visit often. First, on the left is the Alliance, the wiki page, docs.alliancecan.ca, and the second place at the SharkNet website. On the SharkNet website, you can find events, news events, such as the new user seminars, general interest seminars, and the colloquium like this. And also, you can go to the YouTube channel, a SharkNet YouTube channel, at the youtube.sharknet.ca, where you can find the recordings of previous workshops and talks and the lectures. And here's a list of local staff members at Western. We are in the Western Science Center, first floor. These are my colleagues: Tyson Whitehat, Jinghui Ching, myself, Doug Roberts, who's actually from Laurier, and he is responsible for engineering, software, and licenses. And also with us, the sysadmin, Mohammed, and the Fraser. So what we do, we help you with the use of systems, the installation of the software, access to commercial software and the site licenses, debugging and optimizing your code, dedicated programming support, consultation on various research problems, and a grant application for computer hardware and etc. Just email us at help@sharknet.ca. Getting help from beyond the Western. Weekly online service, online office hours at 2 o'clock. You go to this website, there's a SharkNet website, and you go find the training and events on the calendar. Ticketing system, if you are running into any issues with the use of particular systems, clusters, or clouds, send your request to support@tech.alliancecan.ca, and you will get a support through tickets. You can always also find the staff contact information on the SharkNet website. You can find our email, phone number, and expertise if you would like to contact us individually. Okay, next, I will briefly go through the topic of requests for compute storage and cloud resources if your needs exceed default values. As I mentioned, there are three tiers of access: the default access, rapid access, and the third, the resource allocation competition, or RAC. If your needs exceed beyond the default and rapid access service, then you should consider to apply for resource allocation competition. This happens annually. For example, if you want more than 200 CPU cores or over 225 RGUs, or the reference GPU years throughout the year, for example, if you want a 500 or 1,000, 2,000, 7,000 core years, then you should consider to apply for resource allocation competition. Or if your storage, if you need more storage, several hundred terabytes space, as a project space or nearline, you need to apply. Or if you need more cloud resources, you need to apply. Or back to the compute, if you need if you do not need many cores, for example, you do not need over 200 core years, but you need tons of memory per CPU. You should also consider to apply for resource allocation competition. For 2026 resource allocation competition, here's a quick summary of information. Application information session dates. General session September 24th in English and 29th in French. And the GPU requests in particular October 1st in English and October 2nd in French. And cloud requests October 3rd in English only. The deadline for application is November 4th, 2024. And the online information can be found at alliancecan.ca. It is always a good idea to consult with your local staff before you proceed if you're new to this process. Okay, next, what everyone should know about. Who are using the resources? Well, we have a diverse user groups, and here are some of the top 5 users since 2022. We have Professor Biswa Malak, and his group is doing experimental and computational wind engineering. They're using supercomputers to simulate tornadoes and the wind impact to our life. Professor Stentoft is an economist. He's doing a computational finance and using a supercomputer for pricing stock options. Professor Kutnan is a computational chemist and is also a mathematician. He's among the few top users in the country, using billions of cycles on computational chemistry and physics research with application in biological soft matter. Professor Basu is an astrophysicist, His group is doing a large scale simulation of the formation of the universe and supermassive black holes in the early universe. And Dr. Kong is a scientist at the Robarts Research Institute and an associate professor in the Department of Medical Biophysics. His group is focusing on medical imaging and computational brain research. He has his own small clusters at Robarts, and his group is using clusters across the country extensively. What applications people are running? People are running CFD, computational fluid dynamics simulations, environmental simulations, and other engineering computations. Astrophysics simulations, coupled simulations, and that requires lots of compute cycles. Material science applications of AI, machine learning, and deep learning, and economics, finance studies, and political science. What to know? A supercomputer has a lot of computers, but not necessarily a super fast computer. Thousands of computers with the CPU cores and the GPUs and disks, and it requires concurrent processing to get work done faster. Research supercomputers run Linux and not Windows. Software has to support Linux to run on supercomputers. Linux is a public developed operating system, freely available. You would need to know a little bit background theory. For example, the computer architecture, algorithms, and numerical methods. For high-performance computing, it is hard. Efficient programs, algorithms, and the libraries take decades to develop, so use them as much as you can. About Linux, you need to know the Linux and the tools. Using Linux, move around, how to use a shell, how to automate your tasks, and also remember the core utilities of Linux, and how to connect to other computers through SSH shell or SSH, and access to file systems and running programs. These are the basic skills that everyone should have. And also, we strongly recommend you get yourself familiar with Git. Git is a revision or version control system that allows you to manage your research project files more efficiently. And you can use the Git to access and create the Git repositories locally or globally on the internet, for example, on the GitHub. Also, you better equip yourself with the skills and the knowledge, for example, program languages, higher level program languages, of course, Python, R, MATLAB, and the low level languages, C, C++, and Fortran, and some new program languages, Julia, Chapel, and etc. Libraries for parallel processing, OpenMPI or OpenMP, OpenCL, CUDA programming, and numerical libraries, and numeric Xscale accelerators. And the tools, including editors, VI, Emacs, Nano, and nowadays we recommend the Visual Studio Code, compilers, interpreters, and the just-in-time and compiler technology, debuggers and profilers if you're serious application programmers, And you should know how to use these tools, debuggers and profilers, to find the bugs and to improve your code with profilers. Some popular and less popular known items. Data science. Of course, you better learn Python, NumPy, Pandas, Matplotlib, and many other packages. R, data frames, tidyverse, and database, a SQL database, machine learning, TensorFlow, for example, and visualization, for example, PairView and Visit, and much more. And then lastly, let me just briefly mention the training courses that we're running at SharkNet throughout the year. SharkNet offers a variety of training courses: Introduction to Supercomputing, Introduction to Shell, Introduction to Machine Learning, SQL Database, Python for high performance computing, C++, Fortran, GPUs, parallel processing, accelerators, visualization, and much more. In particular, here, the core Introduction to Supercomputing is a comprehensive course. It's a 13-week comprehensive course that covers a variety, a wide spectrum of areas and topics essential to advanced research computing. It's highly recommended to take these training courses. For more details, you can go to the SharkNet training website, training.sharknet.ca. Format and a schedule. These training courses include live lectures, workshops like this, self-paced learning courses with course materials, recorded videos, quizzes, and assignments. And summer schools, every summer we run our summer schools with many courses for 3 weeks. And our summer school is being attended by hundreds and thousands of people from across the country. And how to enroll? Just go to the SharkNet training website at training.sharknet.ca, and the outcome of the taking the training courses is the certificate of completion. Okay, so this is the end of my presentation. We have a couple of minutes to take some questions from the audience.